usual. Do you have the, oh, there it is. Okay. Great talk. Okay, our extended research group goes back decades and involves a whole pile of people. These four happen to be the four that are here at this meeting, so they get top billing. But I want to take this opportunity to acknowledge that I have the unique, blessed position of having Steve Cook, both as a student and as a lifelong mentor. I am sure that I have learned way more from him than he did from me. I just want to thank Steve for that. Okay. Okay, I want to talk about black bass, and they are 17, soon to be 19 species of the genus Micropterus. They're native only to the western part of North America, even though they're found all over the world. The bass fishery is absolutely huge, tens of $billions a year in North America alone, and not surprisingly, in the U.S. alone, we spend over $100 million a year in bass research and management. And when you ask anglers what they want, actually it's very simple. They want to catch more fish and bigger fish. That's all they're interested in. So, with all that economic assessment and all the ungodly amounts of money that we have spent over the last several decades, one would think that we have a management process that is finely integrated, well-oiled machine that delivers more and bigger bass. And wow, are we falling short of that. So, the reason is, first of all, our management toolbox is 100 years old. We've been stocking fish and restricting harvest since the early 1900s or even the 1800s. And we've really rarely gone beyond that with bass. Also, our scientific foundation actually sucks, okay, in my opinion, because we're putting our management programs are dominated by these four myths. One, catch and release angling has no impact. Wrong. Population size structure is determined by prey availability and harvest mobility alone. Wrong. Recruitment is totally controlled by environmental factors. Wrong. And the ridiculously wrong myth 4, it only takes a few successful bass nests to repopulate the lake. And if I had $1 for every time I've heard that from anglers, I'd be a rich man. Okay. Okay, so we really need to understand what's going on. How and why bass do what they do. So that means we need to understand the actual life history of bass and use, instead of these myths, life history theory, behavioral ecology, evolutionary principles to design management programs that actually work. Okay. So a short course in bass life history, which is dominated by two things. One, extended male parental care and female mate choice, both of which are basically ignored by all of the management programs. So, bass move into the shallows, the males move in, build a nest, and court females when they show up. They try to entice them into the nest, but the females make 100% of the mate selection, okay? They're checking out the males. They want to determine who's going to be the best dad, and usually that's the biggest badass out there, okay? And that's who they choose to spawn with. So they spawn for, hello. There we go. They'll spawn for 1 or 2 hours, up to a couple thousand eggs. But after she's done, she leaves and then leaves the male alone to guard the babies for 4 days while they're eggs, and for another 10 to 12 days while they're still larvae in the nest. They come out very undeveloped. But then also for 3 more weeks as swim-up fry and small fingerlings. There's a total of a 5-week period. If the male is removed through angling or decides to abandon the nest, they are quickly decimated by predation. Generally, 50% in 8 to 10 minutes in many of the lakes that we deal with. Okay, so the question is, how extensive is the angling for bass going on in the lakes that we're studying, and what are the consequences? So in 1990, we began a snorkel survey. So we swim lakes and monitor the nests, all the nests that are spawned every 4 days for 7 weeks to determine how many eggs, who are successful, et cetera. Then we come back the next year and swim those lakes multiple times to count the number of 1-year-old recruits. Okay. This shows the 27-year history of what happened in Lake Opinacon. And it shows from 1990 to 2017, 5 different metrics. The blue dot represents a 20% reduction in the number of spawning males. Orange is a 25 or 30% reduction in numbers of females. Green is a 50% reduction in successful nests. Purple is surviving fry, and the bottom line is that there's a 70% reduction over these 27 years in recruitment of 1+ juveniles. Why? Because angling more than tripled over that last 20 years. Okay, so since 2000, it has tripled, and that has driven the population down. So we've found that angling nesting bass decreases reproductive success, and because recruitment in bass, and probably most fishes, is directly dependent on the number of successful fry, it produces weaker year classes. So this is resulting in fewer adult bass, a classic case of recruitment overfishing, even though it's catch and release. In Ontario, there's a closed season for bass. You're not allowed to harvest bass. You're not allowed to fish for bass, but you're allowed to fish for everything else, rendering that maybe the least effective management regulation on the face of the planet. Okay, but we also found, interesting, that these were smaller bass. So now not only are we reducing bass, but we're making them smaller. That's not what bass anglers are asking for. So this is how we always see how fish grow, this nice beautiful curve, which is a population estimate, but no individual bass grows like that. They grow like this, 4 components: pre-maturation growth rate, post-maturation growth rate, the age at maturation, and how long they live. Each of these can be, is a bit plastic and different, but age at maturation is wickedly plastic in all of the sunfishes, including these bass. So, okay, this is actually a typical smallmouth bass population in southern Ontario. It grows until age 6, where it matures at about 400 millimeter total length, spawns for 6 more years and dies. But not all fish do that. There are a variety of other kind of life histories. What is a stunted population? It's basically any population that doesn't grow very big. So we have a number of populations where you cannot find adults larger than about 300 millimeters. Why is that? There's 2 hypotheses. One, there are too many little fish hypothesis. Okay, and so that it's depressed growth because the density of food has been lowered. They still mature at age 6, but just at a much smaller size and just never get very big. That is favored by 95+% of all fisheries biologists in the United States anyway. I am not one of those. But to get out of this, what you would do is you would increase harvest to remove smaller individuals. Actually, some management agencies are going in, electrofishing small fish, and taking them out of the population. Okay. The other hypothesis is not enough big fish. So here, because of recruitment overfishing, either through harvest or through the nest catch and release destruction that I talked to you about earlier, the large individuals are becoming fewer and fewer. As that happens, these fish mature at younger ages and smaller sizes, all the way down to when they're maturing at age 3 at 200 millimeters. 2 quite different things, because in this one, you want to protect those against harvest. So there are 2 different mechanisms that have been proposed, each of which would take an entirely different management approach. There are no management approaches right now that are doing that, but there should be. So here are the 2. And what do the data say? I want to show you 4 different lakes. I like these lakes mostly because they have such different size distributions. These are the sizes, the inch increments, okay, of only nesting males in these populations. And Oddie Lake is a super, super large population with the smallest nesting male being 14 inches, which is larger than the largest male in Bass Lake. The reason I like these 2 is that they're all within 2 miles of each other. They are all connected through Big Rito Lake. They have intergene flow, and they used to, back in the 70s and 80s, all have large, healthy populations. So something has happened. When we look at age at maturation, it goes from 6.8 down to 3.2. It's cut in half. When we look at the size of one-year-old individuals, so early growth rates, these Adi Lake, the trophy situation has the smallest, and the stunted population has the largest one-year-olds. So, what is a population? What is a stunted population? This is what we're seeing, that we're getting actually increased growth because the density of these individuals are so small. It's so low, right? So, but age at maturation is way down here, and they don't live very long. So that's the population we're talking about. And if we start removing these individuals, that's not good. Okay, so catch and release angling or harvest, okay, decreases the reproductive success, produces bad year classes, fewer and smaller, and actually through angling-induced evolution, which is huge here, produces less aggressive. Okay. Which males get angled? Come on, baby. Oh, sorry. Well, the most aggressive ones. Okay, whoops. Okay, so you can see too, we use a standardized fishing situation where the trophy lake had 81% aggression levels that dropped down to 40% here. It's a standardized angling situation. We can, if you want, I can go over it in detail later. But so half of the aggression has been dropped out of that stunted population. Okay, so how do we reverse those trends? We're proposing to use Bass Spawning Sanctuaries, which are areas of the lake that are closed to all fishing, so there's no pike fishermen that are coming in and fishing off nesting bass. And so we've had 2 lakes for a proof of concept, because also in these lakes, there's a huge amount, we're predicting that there would be a huge amount of extra production, as well as it allows sexual selection to occur, so that the females are actually making the right choice by choosing the best males, and the best males are the ones that are successful. So these sanctuaries are pumping out not only lots of juveniles, but juveniles with a more natural high aggression level of genomic complex. Okay, do they work? Oh, they work great. Okay, so we have 2 lakes. One is a largemouth lake, one's a smallmouth lake. This shows that compliance was pretty good. We get 5 times the amount of successful reproduction each year, inside versus outside, and 10 times the amount of recruitment, inside versus outside. So the bottom line is we can do better than we've been doing. And management agencies need to do better, right? They need to up their game and use some more modern techniques. Maybe they need to go back and take Christian's and Thomas's course once we get that going. But they need to have some novel thoughts coming in. And more importantly, I think, is we as anglers need to demand that our natural resource agencies actually do better. Thanks.
Any questions? We have time for 1 or 2.
Thomas.
What about the size of the protected areas? Would you recommend 10% or bigger?
Okay, so we're expanding. Steve and I are trying to expand this. We have to convince the ministry. And we're going to look at 10%, 15%, 20% on a variety of different types of lakes. So back of the envelope calculation, really, that I've done puts it at about 15%. But a lot depends on where on that scale the lake sits. If it's really stunted, it's going to take a much bigger set of protected areas to get it back quickly. Yeah, but that's what we're trying to look at in this much bigger study.
So you looked at 1+ recruitment.
Yeah.
Is there density-dependent population regulation later between 1 and 2?
No.
No.
No, because we can also monitor 2+ers, because the year classes are very distinct until they get up to 3, and then we can also look at in some of the lakes at adults, and that ones correlate. So we were lucky with COVID. We got these huge year classes because there was no fishing, and the biggest year classes ever, and we can follow those. So you can follow those and see that the 1s and 2s and then 4-year-olds that were maturing in these lakes were going. So yeah,
Right.
you can follow that
So
right.
thank you very much.